Okay, thanks for joining today and welcome to today's webinar on Color iMatch 10, the new Formulation Standard. Presenting today is Rich Knapp, the Product Manager for Color iMatch 10. Our Applications and Technical Support Manager, Tim Mao, is also available and will be able to answer any questions at the end of the webinar. I'm Robert Grotans, the Global Technical Marketing Manager at X-Rite, and I'll be moderating today's webinar. Just a few things to go over before we get started. Due to the number of people that are attending today's webinar, we'll keep everyone muted. During the webinar, if you have questions, please use the questions function on the GoToWebinar panel. I will be monitoring the questions, and at the end of the webinar, we'll have time for a short Q&A session. Finally, this webinar will be recorded, and you'll receive a link so that you can review the webinar at your convenience. So with that, I will turn it over to Rich to kick things off.
All right, hello everyone, and thank you for joining us today. As Robert stated, what we'd like to review with you today is a new release of Color iMatch. Color iMatch is X-Rite's industrial formulation product. It supports plastics, coatings, and textiles. So as I go through the presentation today, I'll be talking about each of those segments. But the focus again is on the major new release which we have, which is version 10. And we've added significant new capabilities and features to the product that will both improve performance as well as streamline customer workflows. So just to get started with that, I'll just step through a few things here. Is that what we're looking to do is to improve our color matching performance in all of the segments that I described. So for us, this would be meaning better matches with fewer corrections. We want to improve process efficiencies. And we also want to enhance and optimize legacy data. And the ability to optimize and enhance that legacy data is something that we'll talk about much more as we go through the presentation. But our objective, with this is that with these capabilities, what we want to be able to do in the plastic space is that we will have best-in-class first match and correction performance. And for plastics, that's both opaque or translucent, and for coatings, it could either be fully opaque or non-opaque, but best-in-class first match and correction performance. We're putting in better data preparation and assessment tools, and this ties into the optimizing the legacy data. We've added in rules-based formulation, which is the ability to kind of give you more control over how the formulation proceeds and the settings and interactions with the colorants that you have, as well as tying that into our queuing capabilities. And we've added in the ability to kind of dynamically evaluate achievability. So again, before you start the process of trying to formulate, you can determine is the color achievable or not with your current colorants and settings. And on textiles, a similar thing. So again, fewer steps to an acceptable match. We have search and correct capabilities combined with a new feature that we call dynamic correction factors to automatically adjust dye characterizations. We'll talk about that in more details. And then again, the rules-based formulation that we have in all segments of the product. So to start off then, again, focusing first on plastics, we have developed a next generation multiflux engine. iMatch has had a multiflux engine for many years. Since it's been on the market, and it's kind of been an industry standard for a match engine. Over the last 4 or 5 years, we've been developing our next generation multiflux engine that gives us improved performance across all of the segments that we support. What the engine has, it has new metrics inside of the engine to ensure that the best suited pigmentation is in the best ranked recipes. The intent here is that when we're generating formulas and what we're looking at is formulas that we believe likely have the same components as the target you're trying to achieve, because that's critical for more rapid convergence and correction. We've improved our correction metrics so that we converge more rapidly than we did in our previous version of the software. And the goal of these two things is to get better initial match performance and also more rapid convergence when corrections are required. So if we look at our performance with this engine, and the numbers I'm going to present now as we're comparing the new version 10 to our prior version 9. Again, our performance after one correction is that we're getting twice as many formulas meeting specification, and we're getting much lower average delta E's and far fewer outlier formulas. So again, in terms of plastics and looking at performance after first correction, the new engine is outperforming our old engines significantly, and we're getting much more rapid convergence to an acceptable match. If we take this into coatings, again, coatings looking at an initial formulation rather than the first correction, you can see similar improvements there. So again, in coatings case, and this was a non-opaque system, almost 3 times as many formulas met specification, again, with much lower average DEs and far fewer outliers. So again, the new metrics and the new capabilities that we've added to our engine around optimizations that we perform inside the engine when we're doing a formulation, and new optimization metrics when we're doing corrections inside of the engine have resulted in much better performance in all areas of coatings and plastics. If we take that to the next step, is we've improved our search algorithm too. So again, we have a new search algorithm that's available in the system. And again, we have new metrics here that we're using as well that result in better matches and fewer corrections. And again, the approach we've taken here is a little bit differently than what's traditionally been done with search and correct, because in many applications, search and correct is done as a colorimetric search. So you kind of look for a close match based on color, and then you can rank those formulas. In version 10 of iMatch, we're doing that as well. We start there, but then we have additional search metrics that are based on the spectral shape of the color of the formulas in your database, as well as your target. And we're utilizing these new shape metrics to identify likely formulas, again, formulas that likely contain the same components. So in addition to looking for a good color match, we're looking for formulas that likely have the same components. And then in addition to that, we look at what's the correctability of those formulas. So again, we find, we create a color box, find close candidate formulas, organize those formulas by our shape metric, and then test their correctability. And the combination of those 3 steps is what results in getting us better matches and fewer corrections, because again, identifying the proper components is a key step in more rapid conversion. So again, the goal of this feature is that in a single step, we can get the equivalent performance of 1 or 2 corrections depending on the quality of the database that we're working with. So this capability is available in iMatch 10. In terms of textiles, we use a different engine. So we're not using our multi-flux engine here. Again, we're using more of a traditional single constant approach. But what our experience has shown us is that textile match performance is a combination of a number of things, but it's largely affected by the behavior of your dyes. So again, if your dyes that you've calibrated with are representative of your current processes, you can get good formulations. If for some reason over time the behavior of those dyes has changed, or the dyes that you've been received from one of your suppliers has changed, it can result in poorer match performance. So we've added a feature we call dynamic correction factors, and what this does is when we're formulating and we identify a target, a match for a new target, we look at the dyes that we've picked for that formula, and then we look in your database at other formulas using those same dyes, and we look at their behavior over time. And then we make adjustments to our correction factors based on that historical behavior of those dyes. And so that, in combination with improvements that we've made to our engine around substrate and dye and process control factors, that combination of capabilities has given us significantly better textile match performance versus our prior products. So what I'm showing you on the screen here now is the performance of iMatch 10 versus iMatch 9. And again, what we're seeing is twice as many acceptable formulas, and again, with lower average DEs and far fewer outliers. So again, good performance improvements in all 3 of the segments that the product supports, so in coatings and in plastics and in textiles. The next few slides I'm going to go through talk more about specific features and functions that we've added into the software. So the first one is our Colorant Editor, or our assortment editor. It has multiple names, but this is the tool that we use to generate the calibration or the optical data that drives formulation. And our goal here was, the formulation is only as good as the data that you provided. So we wanted to provide our customers with better tools to assess the quality of their assortment, but also a tool that provides them with actionable information. So again, if the system can make recommendations about various letdowns or show you their behaviors, it helps you to make good decisions in calibrating and building your optical data. So we also include information on your process variability here, because again, that's a key element in how well the matching will perform. And we also added in a metric that we call prediction confidence. And again, I'll explain that. What we mean by prediction confidence is almost every formulation system available today will show you a good theoretical delta E value, or a good theoretical match. But when you go to make that match and then you measure it and you look at it, it often is different from what was predicted. And that happens in every system. What we've added in version 10 is our prediction confidence metric, which is based on your process variability that we've identified. That prediction confidence can be included in our scoring algorithm, so that when we're ranking and presenting what we think is the best formula, we can include its achievability in that ranking, so that when we present a candidate formula to you and we make a recommendation that we think this is the best match, it can also, it's also our understanding that this is also the most achievable match. So we've combined achievability and match performance into this new metric, and this is available in our assortment editor and available in the formulation parts of our product. But again, the key takeaway from this tool is that, again, is providing actionable information to the user to help them optimize and improve their calibration data, which in turn will result in hopefully better color matching. Another feature we've added is a Gamut Viewer. And again, the intent with this feature is to show achievability. So again, based on the current assortment of colorants you've identified or toners you've identified, we can generate the shape that's shown on the screen here, which is showing the achievability gamut of that set of colorants. And then what we can do is we can overlay on top of that your targets. So again, any targets that are within gamut are shown as the green dots. The ones that are red are out of gamut. The shape is in 3D, so it can rotate. So if you see red dots inside of the shape, they're on the outside, on the back side of that. But the intention here, again, is to save time and to save waste. So again, if we can graphically show you at the start of your formulation process, if it looks like a color cannot be achieved, then you can make decisions at that point around expanding the gamut by adding colorants or changing your settings. But again, saving you the steps of going through, starting a formulation, having to mix it up, measure it, and realizing that you can't get there, and maybe not realizing you can't get there until after one or two corrections. So again, generating a lot of waste material and a lot of wasted time and effort. So again, a tool to help you to see the achievability at the start of the formulation process, so that you can make decisions around how to proceed with matching that particular color. We have added in expanded formulation rules into the software. And again, these are fully integrated into our formulation process. Formulation rules can cover a lot of different things. So again, we have the ability to associate metadata to colorants and toners. So again, we can have where the engine can select colorants based on particular attributes. An example could be if it was plastic, fire retardancy, or if it was in coatings, it could be percentage of volatile organic components, things like that. So we have these abilities to select the candidate colorants based on that type of information. But we've also added in the ability to identify preferred colorants or restricted colorants, and to be able to select and pass that information to the engine when it's formulating, so it can adhere to those rules. And we also have the ability now to enter colorant pair restrictions. So this could be something like, I have two colorants and I don't ever want to use them in the same formula, or if I do use those two colorants in the same formula, I want to control the ratio or the amount of those colorants. So all of these rules can be predefined, and then once the rule sets are predefined, when you're in formulation, it's a simple checkbox where you can pick the appropriate rule set that you need to use for the particular material or process or specification that you're working to. And the formulation rules can also be additive. So if you have different sets of rules, by clicking more than one rule, all of the restrictions for that rule are added up together and used in formulation. The formulation rules are also then integrated into our queued formulations. So we have the ability to queue multiple formulations. And again, this feature can be used in a couple of different ways. So again, if you have a color that you want to match and you need to match it under several different sets of specifications or conditions, you can do that in the software. So you can pick the color, associate a rule to it, and then use that same color with different rules, and the system will show you the results of formulating that target color under different rule sets. Or if you're formulating large amounts of colors where maybe you're trying to generate a fan deck or something like that, and you want to cycle through different sets of formulation rules with all the colors you're matching, we can have that capability too. So we can combine our integrated formulation rules with our batch formulation capability. We've added a directional adjustment for formulation. Again, the intent here is that customers have often told us they have variations between their lab and production processes, or they have variations just because of the nature of the material that they're working with. An example that we often see is someone, say, making like stucco, where there's a surface characteristic to it, a surface effect to it, so that when the material dries, it has kind of a 3D surface, and that 3D surface influences your perception of the color. So if you can quantify that type of behavior, or if you have known shifts between lab and production because of additives and things you're adding, we can take that information into account in our formulation process. So we can directionally adjust the formula, by LA or B at the point when you're formulating to compensate for these other shifts in color that may occur later in the production process. So this is available in version 10. We've significantly improved our batch recycle and waste work-off capabilities. So again, these two functions are related, but there's a little bit of a difference between them two. Batch recycle is essentially and I'll use a coatings example for this one, essentially would be if you had a can of material and it was off color and you want to add something to that, but maintaining the restrictions of the can or the size of the container that it's in, and try and move that color to match something else. And so that's what batch recycle does. Again, you can put in the quantity, you can put in the max add, and the system will formulate an add to what's in the can or into the container to get you a good color match. Again, this is done with just a single measurement of the batch. So whatever that waste material is, you measure it once, and then you pass that information to the software, and it'll generate a new formula for that. Waste work-off, again, best way to illustrate that may be a plastics example. If I was a master batcher with a large amount of like regrind material where I have a large quantity of waste material and I want to work that off over multiple formulations, we have the ability where we can measure that waste material once, incorporate it as kind of like a colorant or a toner, but it's identified as a waste. And then if you would tell the system you want to use that waste, it'll track how much of the material you have, it'll track your batch size, and then you can consume and work off that waste material over multiple formulations. But again, the importance of this feature, again, is it's saving of time, and it's also has an environmental factor, because again, the cost and the problems associated with disposing of waste material are increasing, and this tool is an effort to help with that. So again, being able to utilize as much of your waste material as possible saves you time and money, but it also has an impact on our environment. And so again, this kind of takes me to the summary part of the presentation. So again, just to kind of review a lot of the features that we've talked about, is that version 10 has a next generation multi-flux engine that gives us better performance in all types of coatings and plastics. We've integrated dynamic correction factors into our textile portion of our product to give us better textile performance. We have the more advanced search algorithms that utilize color and spectral shape to identify kind of the footprint of the target and better identify the components that we think are in the formula to give you better conversions. We've built up a better set of tools in our calibration editor to help you make good choices and make good decisions as you're building your calibration data and provide you with actionable insights on that data. We have the Gamut Viewer with the target overlay to show achievability. The formulation rules fully incorporated into our matching process and also incorporated into our batch queuing or our formulation queuing. We have the improvements in batch recycle and waste work off, and we have the directional adjustments of formulas where we need to compensate between lab and production or lab and a particular process. So with that, that kind of brings us to the end of the presentation portion of the webinar. And at this point, we'd like to host any questions that you may have.
Thanks, Rich. Yes, if you haven't submitted a question yet, feel free to do so now. It looks like we already have a few questions coming in, so we'll get started. First question, how does the Multiflux engine improve the predictions of translucent plastics?
I think there, again, there's a couple of things there. Again, is with translucent plastics, the way the software works is we have different measurement modes. So we can measure for plastics, we can measure reflectance only, overlight over dark, reflectance transmission, or transmission only. So again, in terms of translucency, it starts with the measurement. So we measure, again, if we're trying to control translucency, we'd probably be reflectance transmission measurement. So again, we start with that measurement point. But then within the engine itself, again, comparing version 10 to version 9, we have these additional optimizations that are really utilizing the shape of the curves and the shapes of the colorants to better identify candidate components and incorporating that in our formulation process, as well as new optimization metrics that we've developed that give us more rapid convergence. Tim, do you want to add anything to what I said?
No, I think you're right on, Rich. I mean, obviously the ability in a translucent situation to be able to measure the sample or the standard in both a reflectance and a transmission and apply those new metrics to the data coming from both sets of data essentially that we've measured in this new engine is what's going to drive us to matching not only the color but also matching that opacity or translucency that you've got in the standard that you're trying to achieve.
Next
Thank you, Tim.
question, when will iMatch 10 be available?
Our release date is mid-May. We're targeting May 13th, but mid-May is our release target.
How do you measure waste? Do you need to know what pigments are in the waste?
First part of the question, how do we measure them? We just measure them with, depending on what type of instrument you have. We do not need to know what is in them. The system will automatically generate what it thinks is the formula for that, and then use that for correction. So again, you don't have to tell the system what you think is in the waste. Tim, I think maybe you can add to that too.
Yeah, so I mean, the measurement is of course going to be measured the same way you've measured everything else, all right? And then as Rich said, we're internally generating a formula, right, to kind of understand and predict what's in there based on its spectral shape. And so we use that information then, of course, when we're using it to formulate, we're able to kind of calibrate, if you will, that waste material like it's a colorant, and then use it like it's a colorant when we're doing formulations. Because of course, when we're doing creating colorants, entering them into the calibration sets, we're essentially doing the same thing. We're measuring those and getting their spectral shape, and here we're predicting the colorants that are probably in that waste material to be able to do those calculations.
Related, will the waste to work off function help you select which waste is the best to start with?
We don't specifically have something for that, but again, since the wastes are part of our combinatorial process, I would think if you select multiple wastes, again, using some of those metrics that I talked about earlier that are in the new engine where it makes colorant choices and formula choices based on the shape metrics, that it may not utilize all of, it may choose the appropriate waste. Again, maybe Tim, you have some thoughts on that,
Yeah.
but that certainly should be possible given how waste is integrated into the formulation engine.
Right. Yeah. Essentially, that waste is just another colorant as far as the engine is concerned, right? So just like the math engine is capable of picking out, if I've got, if I'm in coatings and I've got 20 different colorants in total, I can go generate a formula for this green I want to match and tell it to include all the colorants. The math engine's not going to put red in a green, most likely, right? It's going to use the colorants that make sense, and it's going to treat the wastes just like colorimetrically and spectrally, just like it does the other components. And so it can properly select the right waste to use.
Can the software graph in CIE XY color space?
In terms of like a color plot?
Yeah, I believe that's what they're asking.
We do not draw in X. We do not have an XY plot at this time.
Can wood stains and effect coatings be formulated?
Those are two interesting things. Wood stains, yes, that's something we have successfully color matched with our multiflux engine. In terms of effect, I think the issue there is what type of effect is it. So again, if it's an effect where it would require something like a multi-angle instrument to measure, like automotive coatings, the answer there is no. That's a different product that we're developing. But again, if it's an effect, some type of an effect plastic that may be able to be characterized by a specular included, specular excluded measurement, then again, we have not had a lot of customers who've done that just yet. But is our expectation that with version 10 that we would have some control over those type of effects that can be characterized that way with the new engine.
We have time for a couple more questions. How many mixes are needed to characterize a single pigment?
Tim, I'll defer that one to you.
Sorry, I was on mute. It depends a bit on what kind of a set of colorants you're trying to create. If you're doing that for paint and you're doing an opaque only, so all of your samples that you're measuring in are opaque, all of the colors you're going to formulate, you're formulating for opacity because that's the whole purpose of the paint you're producing, right? That's going to be a smaller set, in the maybe, again, it will depend a lot on the resin you're in and the base you're using and all that, but we're probably talking 5 or 6 letdowns per colorant. If you're doing something where you're going to be doing plastics that might be opaque, translucent, and even transparent, and you're doing both reflectance and transmission measurements, now you might be talking more like 8 to 10 samples per colorant, simply because we need to get them. When we start dealing with the different opacities, we have to get the same mixtures at different opacities to understand not only how, as I add more colorant, not only how does it change coloristically, but how does it change opacity-wise. So it's a bit determined by which kind of formulation you'll be doing. The good news for you is if you're going to go down this path and you were going to create a new one, my applications team is going to work with you directly, and we actually have a questionnaire we send to people about the colorants that they will be using and what kind of formulation they're doing, and we come back to you with a spreadsheet that lists out, here's all the samples that you need to prepare, and it's already scaled to whatever size lab samples you make and all of that.
So we're actually out of time for any more questions. If we didn't get to your question, we will follow up with you, and one of our tech support people can help answer your question. I just want to say thanks everyone for joining today, and thank you for your questions. Again, you will receive a recording for this webinar. Have a great day.
Thank you, everyone.